Hello, Luke. Welcome to Lesson 44. So today we're going to be talking about adding rational expressions. And recall what a rational expression is. A rational expression is just a fancy way of saying a fraction. So this might be a good thing to write down in your math notebook. Rational expression. It is a fraction. It's as simple as that. We're not going to make it any more complicated right now. So a rational expression is a fraction. Remember what that is, because we'll be using that term, rational expressions, a lot throughout the year. So put this in your notebook, and then we can move on. So today we'll be looking at adding rational expressions. So if I have a fraction, and we'll start simple. Let's say I have something like, 2 sevenths. And I want to add that to another fraction, say 3 sevenths. All right. Remember, when we're adding fractions, we add the numerator. We don't touch the denominator when they're the same. All right. So, and that's really the first step. The first step is to ensure that the denominator is equivalent in both fractions. They must be the same in order to add these. And then when we add them, we add the numerators. And 2 plus 3 is 5 over 7. So remember, when we're adding fractions that have common denominators, that common denominator stays throughout the whole process. All right, we end up with an answer with the same common denominator. That's what we want. We want everything to have the same denominator throughout the whole thing. All right, the numerator is what's going to get added here. And that's, again, simply 2 plus 3 in this case. So if we convert this over into some variables, we might have something that looks like this. If I have 2a over, we'll say 9, plus 5a over 9, again, this is pretty straightforward. We recognize that the denominators are the same. It's the first check. We need to make sure that they're the same. So we know that we're good to add this. The new fraction is going to have the denominator as a 9 as well. And now we can add the numerators. 2a plus 5a is, well, they're like terms, so I can add them. 7a. So we have 7a over 9. Now, if I have something like this, 3x over 11 plus 7x, well, let's make this a little different. Let's go plus 7y over 11. Again, first step, look at the denominators and recognize that they are equivalent. So our new denominator will be an 11. We can do that much right off the bat without even doing any math. Secondly, we look at our numerators. Now we can add them. 3x plus 7y. These are not like terms, so that stays as a sum in the numerator. 3x plus 7y. There's nothing we can do. But we can place that whole sum over a single denominator. All right, so that does kind of arguably kind of clean up the look here a little bit. Now we're just over one. We've created it as one fraction instead of two, but there wasn't really a whole lot of simplifying that we could do there. All right, so that's really all we need to know in regard to adding fractions that have common denominators. Pretty straightforward. We just add the numerators. So the big question then is, what happens if the denominators are not the same? So what happens if I have, well, let's start again with an easy one, 3/4 plus 1/2 equals what? All right. Now here, again, the first step is to always look at the denominators, and the denominators are not the same here. So the first step now becomes changing those denominators into a common denominator. And we've done this many, many, many times over the years. So hopefully this, again, is just a straightforward review, and you're very bored right now. But on the assumption that maybe you're not bored and this is a good refresher, let's just remind you on how we would do this. So we make our fraction. We know we're going to have our fraction, and we need to find our denominator. What denominator am I going to put here? I can't put a 4 or a 2 because that wouldn't make all of these the same, right? So we need to actually change these denominators into something that's the same. So we're going to rewrite these two fractions. Only we're going to rewrite them with a different denominator, something that would be equivalent, the same for both. So to do that, we need to find our least common multiple, which if you recall, we did that in, I think, lesson 43. So what is the least common multiple of a 4 and a 2? In other words, if I take each of these numbers, what multiples would be common between these two? And particularly, what is the smallest multiple that would be common? So if I have a 4, and we learned this in our last lesson by looking at the greatest common factors, right? By looking at the factors of these numbers. So if we take a 4, we factor it, we get a 2 and a 2, we factor a 2, and we get just a 2. And then remember we said, what numbers are we dealing with here? Well, in this case, we're only dealing with 2's. What's the most 2's I can pull out of each? Well, I can pull 2 out of this one. That's the most I can pull out, and that's it. So the common denominator is 4, right? Or the least common multiple, I should say, is 4. That's what we're going to use as our least common denominator as well. We're going to use 4 in both. So you should have been able to do that in your head, just looking at that 4 and 2. What number can both of them go into? And the smallest number that both of them can go into. And the answer would be 4. Right? But I'm just kind of taking these steps here because those are the steps we'll be using when these denominators aren't quite so easy. All right. So we have our least common multiple, which was the 4. We've used that as our least common denominator now. Now we need to figure out what goes into the numerator. Well, we've changed the denominator, so we can't just put the same numbers in the numerator. We have to change the numerators as well, all right, in order to make these two expressions equivalent to each other. We don't want to change the values here. So if I have this 4, and that 4 has now become a 4, the question you need to ask yourself is, what did you multiply this 4 by to get it to become this 4? Well, in this case, that's straightforward. We just multiplied this 4 by a 1 to get to this 4, right? So maybe if I put that right here, we multiplied this by a 1, okay? And then we're going to have to multiply the top by a 1 as well. 3 times 1, which is going to give me 3, right? So, and bear in mind what's happening here. We have 3/4. We're multiplying it by a 1 over a 1. And a 1 over 1, remember, is just a 1. So we're multiplying 3/4 by 1, which isn't going to change the value of 3/4. The value, the amount of pi, or however you want to look at it, is the same. All right. Now the second fraction, what did we take and multiply 2 by to get to this 4? All right. 2 times what is 4? 2 times 2 is 4. So we need to multiply this fraction by a 2 over a 2. Right. And again, I'm just going to set that up here just for demonstration purposes here. 1/2 times 2 over 2. Again, recognize that I'm taking this fraction and I'm multiplying it by essentially 1. 2 over 2 is just a 1. That's not going to change the value of this fraction. It'll change the numbers, that's for sure, but it won't change the value. That's the beauty of multiplying fractions by, something over itself. All right, because that something over itself is equivalent to a 1, and we're multiplying a 1 by anything, we just end up with that same thing. So 1/2 times 2 over 2 is, in fact, 2/4, but 2/4 and 1/2 are exactly the same amount of pi. All right, there is no difference between them other than the numbers. They're equivalent fractions. And that's why we're able to do this. We're not changing the value of this expression, but we are changing the numbers. All right, so now we have 2 times 2. That gave us the 4. Now we need to take the numerator and also multiply that out. 1 times 2 is 2. Okay, so now we have equivalent fractions. 3/4 is equivalent to 3/4. 2/4 is equivalent to 1/2. So we haven't changed the expression value. However, now we've made it so that the denominators are equal. They're the same. And we're back to the original set of problems. We have an expression that we're adding, and the denominators are the same. So we can do this now. We can say that the denominator for the solution is going to be a 4. Remember, we want the same thing all the way across. And then in the numerator, we have 3 plus 2, which is 5. So we end up with 5/4. Now, that's an improper fraction, but that's all right. We'll leave it as an improper fraction right now. 5/4. Okay? All right, let's try another one with maybe some variables. So if I have x over a, and I'm adding 5x over b, okay? And I want to simplify this. I want to add this up. Well, again, we look at our denominators and we recognize that, okay, a and b are not the same. So we do not have a common denominator. So we need to recreate this problem so that it has common denominators. So the first step is just to draw our fractions and our plus sign. Recognize that that's what we're doing. We're rewriting this problem so that the denominators are the same. Now, in the denominator, what is going to be the least common multiple of a and b? Well, that's, remember, pretty straightforward. All we're doing is we're taking a's and b's, and the most out of each one is 1a and 1b. So we're going to take the common denominator is going to be ab, one of each, a times b. All right, so we have a times b. That's the common denominator. Now we need to figure out what this numerator is going to be, because remember, that's going to change. So we need to ask ourselves, what did we multiply each of these denominators by to get to this common denominator? Well, we multiplied this a by a b to get to ab. So we need to multiply the numerator by a b, right? And the x times the b is going to give us an xb. And then down below, we have ab. What did we multiply this by to get to the ab? Well, we multiplied it by an a, right? B times a is a times b. All right, so we multiplied that by an a. We need to multiply the numerator by an a. So we end up with 5xa. All right. Now we can add this because we have common denominators. Unfortunately, the numerators are not like terms, so we can't add them together. So we'll just write them in alphabetical order maybe. bx plus 5ax all over a b, the common denominator. That would be our solution. Okay? All right, let's try some more here. And these ones maybe you can do on your own first, and then we'll do them together. Let's say, well, actually, let's just pull a couple from the book here. What if I've got 4 over b plus 1 over c plus 1/2. Go ahead and pause the video and try this on your own, and then we'll do it together. All right, so the first step, are the denominators the same? The answer, no. So we need to rewrite this with common denominators. So we're still going to have our 3 fractions, and we're still adding all of those, so that doesn't change. Now, what is our least common multiple between a b, a c, and a 2? Well, we're dealing with b, c's, and 2's. How many b's do we have? 1. How many c's? 1. How many 2's? Well, 1. That's the most we have in each of these. So we end up with a common denominator that's simply 2 times b times c, 2bc. We're basically using everything. So we have 2bc, 2bc as the common denominator. Now we need to figure out what the numerators are going to be. So let's figure out what we use to get this common denominator. So the b was multiplied by what? The b would have had to have been multiplied by a 2 and a c. So this would have had to have been multiplied by a 2c to get to this 2bc here. So that's what we need to multiply the numerator by. So 4 times 2c, well, that's going to be 8c, right? Now going to this one, we have 2bc, of course. And now what do we multiply this c by to get to that? 2b, right? All right, so now we multiply the numerator by 2b. 1 times 2b is simply 2b. Then the third one, What do we multiply this 2 by to get to 2bc? Well, we multiplied it by bc. So we have to multiply the numerator by bc. 1 times bc is just going to be bc. All right? Very good. Now, just be cautious here. Sometimes I've seen people look at this and go, oh, great, but look at this. I've got a c up here and I got a c down here. It's all multiplication. I can cross those out. Right? So a lot of people will say, why can't I, cross those out? Cross cancel. Why can't I cross these out? And I have a 2 here and an 8 here. Why can't I cross that out and get a 4 left? Well, don't do that, because if you do that, all you're doing is reducing the fraction back to what you started with. You'd end up with 4 over b, which is this. So in this particular case, we do not want to simplify these. We want to keep these expressions unsimplified. The whole point was to unsimplify them so that the denominators are the same. And if we start simplifying, we're going to end up right back to where we started, which is not what we want in this case. All right, so watch out for that. Don't fall prey to that. Don't think, oh, look at that, b and b, I can cross those out. 2 b's, and 2 2's, I can cross. No. Don't do it, because it's just going to bring you back to where you started. All right. At this point, we want to recognize that we have 3 common denominators, so we can now add them. So all of these are going to be over 2bc. The denominator doesn't change. Remember, we're looking for the same denominator across the board. In the numerator, that's where we add. So in the numerator, we have 8c plus this numerator of a 2b plus abc. There's no common terms here, like terms. So therefore, we can't do anything more. This is the solution. All right, let's try another one. So let's say we've got, and again, I'm just going to pull this straight from the book, 5 over x. So go ahead and pause the video, give this one a try, and then we'll do it together. All right, so again, we're looking for common denominators. We do not have them, so we need to create them. So we're first going to write our fractions here. We have 3 of them. What's the common denominator in this case? Well, pretty straightforward. It's just, let's see, we'll put it in alphabetical order, bcx. So the bcx is going to be our common denominator. In the numerator, what did we multiply this x by to get to the bcx? Well, we multiplied it by bc. So 5 times bc is going to be 5bc. What did we multiply the b by to get bcx? Well, cx. So x times cx is going to be cx squared. Right? Did you follow me there? I'm doing some of this kind of more in my head. B times cx is what we needed to get to this. So we multiply this by a cx. The x can be multiplied by the x to give us x squared. All right. Moving on. C times what is bcx? Well, it'd be bx. So a times bx is what we'll get in the numerator. And now we're ready to add. It's all going to be over a bcx. And we have 5bc plus cx squared. I need to extend this here. Plus abx. That would be our solution. All right. Let's try one last one here and see how you do. All right. So why don't you pause the video, try this one on your own, and then we'll do it together. Okay, so let's try this one out. We're looking for a common denominator, and we don't have one, so we'll set this up again as our 3 fractions. First fraction, well, let's see. We have a c squared, and then we have a 4c to the cubed, or 4c cubed, and 3c to the 4th. Okay, so let's find our, this one's a little more complicated. We might not be able to do it in our heads as easily. So let's start by looking at the coefficients. This one's a 1. A 1, 4, and 3. The ones that matter are the 4 and the 3. What would be the least common multiple of a 4 and a 3? Now you might say 12, which is great. That means you're doing it in your head. But let's just write them out as factors again. 4 would be a 2 and a 2. A 3, of course, is just a 3. So what numbers are we dealing with here? We're dealing with 2s and 3s. What's the greatest number of 2s we have in any one number? Well, we have 2 of them. And what's the greatest number of 3s? A 3. And 2 times 2 is 4, times 3 is 12. So the least common multiple, or the greatest common denominator that we're going to be using here, or the least common denominator, is going to be a 12 as far as the coefficient goes. So we can write a 12 in each of these. Now let's look at our variables. We're dealing only with c's, right? So what's the greatest number of c's in any one term? We have a c squared, c to the third, c to the fourth. Well, the answer would be c to the fourth is the greatest one. Therefore, that's going to be what's in our least common multiple. So our least common multiple is going to be this. That is what we're going to use as our least common denominator. Boom. All right, so there is our least common denominator. Now we can figure out our numerators. So what do we multiply this c squared by to get to this 12c to the fourth? We multiplied it by a lot. We multiplied it by a 12. And we also multiplied it by c squared, right? Because c squared times c squared would give us c to the fourth. So we multiplied it by 12c squared. So that is what we need to multiply the numerator by, 12c squared, which is going to give us a 12ac squared, if I write it in alphabetical order, right? Now the next one, 4c to the third, what did I multiply that by to get 12c to the fourth? Well, I multiplied the 4 by a 3 to get to the 12. And then the c to the third, I multiplied that by another c to get to c to the fourth. So I multiplied it by 3c. So that's what I need to multiply the numerator by. So 3 times 3c is going to give us a 9c. And the last one, 12c to the fourth. So I multiplied this one by a 4 to get to the 12. The c to the fourth, I just needed to multiply by a 1 to get to c to the fourth. So in this case, we're really only multiplying the numerator by a 4. So we end up with 4m. All right. Now, if you didn't quite understand that process, rewind this and look at it again until you understand how that worked. It's pretty straightforward. It's very similar to what we were doing before. It's just the variables and numbers are a little bit more complicated. But if you can do that, you can do this for any problem. All right. Okay, so let's add this up now. So we have a common denominator. Now we're ready to add the numerators up. And of course, the numerators, the sum of the numerators are all going to be over this 12c to the fourth. So we have 12ac squared plus 9c plus 4m. Go ahead and look at this. There aren't any like terms in there though. You'll find there usually isn't. And we're going to then box that as our answer. All right. So that pretty much is as far as we need to go today. One last thing I'm going to throw at you here. I've created kind of a flow chart on how to do these problems, and I've actually placed it in the OneNote section. I think it was the homework section. So you can refer to that and print it out if you'd like and use that as a homework sheet. All right, so I actually did a little bit of your own work here. Rather than having you write out all these notes in your notebook, I thought this might be a little bit more of a straightforward way to do it. So you can either copy this directly into your notebook or print it out and stick it into your notebook so that you've got it to study for homework. All right, it's basically just a flow chart showing how we go about solving these problems. So the first question, are the denominators the same? If the answer is yes, such as in this green problem, then life is wonderful. All we need to do is add the numerators and place the sum over the common denominator. So we're just taking the 3x plus 4a and putting it over the common denominator, y squared. Life is great. The denominators are the same. If the answer to that question is no, such as in this problem, then we need to go this route. And we need to go to the first step, which would be to create a common denominator, finding the least common multiple of the given denominators and placing it in the denominator of the new fractions. So here we just looked at this a and b and said, okay, the common denominator is ab, and we placed it under both fractions. Then we move on to the next step, which is to multiply the numerators by whatever was used to multiply these denominators by to get to this common denominator. So we needed to multiply this a by a b to get to this ab. So we multiply the 6 by a b. We needed to multiply this b by an a, so we need to multiply the 7 by an a. All right. And then the final step after that is very similar to this first step in the green section, and that is we're just adding now the numerators and placing them over the common denominator. All right, so that is kind of the rundown, the outline of how this whole process works. So study that for homework so that you can be very sure of yourself when you're working with these rational expressions. All right, we'll stop it there, and I will see you tomorrow.